All right, so give this a shot here. We've got a sphere, and inside of the sphere we have a cone. And the question is, what's the biggest cone that we can fit inside the sphere? And so what I'm imagining is a cone. I'm going to draw it upside down for reasons I'll explain in a second. A cone going down like this, and we know that the radius of the sphere is 10, but we don't know what the radius of the cone is, and we don't know what the height of the cone is. But we know that the volume of a cone, the formula is 1/3 pi r squared times the height. So what we need to do is figure out how can we relate the radius and the height, and use that to figure out the biggest cone that will fit in there. Okay, so what I'm thinking is that if we imagine the sphere centered right here along an x and a y axis, what we could think about is a point along the sphere as being a point on the unit circle. And so if I look at this x comma y point right there, what I know is that x squared plus y squared is going to equal 10 squared. So x squared is equal to 100 minus y squared, for example. It could have done the other way as well. And when I look at the radius of the cone, the radius of the cone is just equal to x. When I look at the height of the cone is just equal to 10 plus y. So I can rewrite my volume of the cone like this: 1/3 pi times x squared times the height, 10 plus y. Then I can take x squared and substitute in right there. So now my volume of my cone is a lot better. 1/3 pi times 100 minus y squared times 10 plus y. So I'm going to use a product rule here because we're going to take the derivative and set it equal to 0. And I'm going to factor out the 1/3 pi. So the derivative of the volume is going to be 1/3 pi times f prime g plus f g prime, which is just 1. And I'm going to take the derivative and set it equal to 0 because I'm trying to optimize. Now, it was nice to factor out this because I can divide both sides by 1/3 pi and it's gone. And all I have is what's left over on the inside of the parentheses. I'm going to distribute. So we have negative 20y minus 2y squared plus 100 minus y squared equals 0. So we end up with negative 3y squared minus 20y plus 100 equals 0. You can flip the positives and the negatives. I wonder if this is factorable. Oh gosh, let's try to factor it, and then we can do quadratic formula if it doesn't work. So maybe we have, let's see, you could do 1 times 100, 2 times 50, 4 times 25, 5 times 20, or 10 times 10. And if I wanted to get 3y squared, it'd have to be 3y times y. And I just don't think this is going to work out. Maybe it will with the 10s, of course. 10 here and 10 there. And actually, there's a nice little connection I'll make in just a second to how I knew that the 10s would work. So 10 times 10 is 100, if I do a positive 10 here and a negative 10 here, I'll get some answers that make sense. Because this negative 10y and this positive 30y make the 20y in the middle. So this tells me y equals 10 thirds, and this tells me y equals negative 10. And I want you to think, how did I know that negative 10 was going to be one of my solutions? And the reason is that would optimize the volume in the wrong direction. If y is equal to negative 10, then I have a cone that has no height because the height was 10 plus y. So that'd be the smallest cone I could fit, 0. So I knew this was it. It's a false solution. We could throw it out. So we want the 10 thirds as our height. Now we want to find the volume. So we take our 10 thirds and we put it back into the volume formula over here. So the volume of the cone is 1/3 times pi times x squared, which is just 100 minus y squared. So 100 minus 100 ninths. I just squared 10 thirds. And then 10 plus y. So 10 plus 10 thirds. Excuse me squeezing that in there. So let's try to simplify this a little bit. We have pi over 3. This is 800 over 9. And then 10 plus 10 thirds is 30 thirds plus it. So we have 30 thirds plus 10 thirds makes 40 thirds. So whatever this comes out to be, let's just say it's 4 times 8 is 32. So we have 32 with 3 zeros. And then we have 3 times 9 times 3 makes 81. And then there's a pi on the end. So that's the volume of the cone that fits in there. All right, please ask questions. If anything was confusing, let me know how I can help.